So today we're going to be learning an application of something we've already done. Now, before we get to the formulas of how we're going to do this, let's just take a look at kind of a simpler example that we can do without any calculus. So here we have the temperature, and it's given by our function g of t. And so let's just say this is over hours. The temperature's varying a lot, right? So it starts at 10 degrees, it goes up to 60, 50, 40, and then back down to 10 degrees for the last 2 hours. And we want to know what the average temperature is between hour 2 and hour 6. So just to kind of remind you, averages kind of work up. One thing you want to get is kind of a total of some sense, right? So between hour 2 and hour 6, the temperature is 50, it's 40, it's 10 degrees, and then it's 10 degrees. Right, and so this is a total. And now to make it an average, though, we need to divide it by the number of hours. And I'm actually going to kind of write that up front. I'll write 1 divided by 4, right? And so this is this is more the amount of time, right? And so our average in this case would just be 1/4 times 90, 100, 110. And so you'll get 27.5 if you work that out in your calculator. Now, so how would we do this with calculus? So we're going to actually have the same kind of format. We'll have 1 divided by 4 out front, our time, but our total will be something else. So we'll still have our time this way, but our total is going to be something else, and our total, kind of think, basically our choices here are an integral or a derivative, which is more like a sum. And this is really, if you kind of think about it, this is a left-hand sum of some sort, right? So this is really, we're going to be doing an integral here. And we'll be doing the integral from 2 to 6 of g of t dt. Now, so the formula in general is just going to be 1 over b minus a, so that's our 1 over 4. So in this case, it would be 6 minus 2. And then we'll take the integral of our function between those two areas. So if we're trying to find the average from a to b, this is our formula. So we can get kind of weird questions just like they give us a function. And they say, what is the average value of this function? So it may not make as much sense as in the temperature one intuitively. But what we're getting is we're getting 2 plus 3x. It looks something like this. And they're saying, what's the average value between 2 and 4? Right? Some people might like to think about this as you've kind of filled up a pool, and this is a really weird pool, and you've put a top on it, and we're trying to find the value that it would even out to if we kind of released this top, right? So our value would be somewhere in here, and so to do that we're going to use this formula, right? We'll use the 1 over 4 minus 2 times the integral from 2 to 4 of 2 plus 3x dx. Now you can use any method you'd like to solve this integral. I would encourage you to do it with the section we've been doing with definite integrals, just for the practice. So this would be the 1 over 4 minus 2 will be 1/2. The integral itself will be 2x plus 3x squared over 2. And this is all going to be from x equals 4 to x equals 2. Now if you plug in your x's here, you will get 1/2 all the way out front. And then from x equals 4, so we'll have 2 times 4 plus 3 times 16 over 2. And then we'll have minus 2 times 2 plus 3 times 4 over 2, right? So this is the x equals 4, and this is the x equals 2. Now you can work this out in your head if you're good, or you can just do it in your calculator. If you do it in your calculator, you will get 11. And so basically what we're saying here is you had a pool that looked something like this. If you took off the cap, the water would kind of level out at a height of 11. You know, some of the pool was originally above 11, some of the pool was originally below. You take off the cap, kind of evens out right there. Now, let's take a look at what if we got this in a graph. All right, so what is the average value from x equals 2 to x equals 6? Well, it's just going to be the same formula, except we end up having to use the we end up having to do the integral a slightly different way, right? So our formula is 1 over 6 minus 2, the integral of 2 to 6 of f of x dx. Now to calculate this thing, though, calculate this integral, you have to do that using using shapes, right? So we'd go from 2 to 6, and to do this we're going to have to break it up into triangles and rectangles, right? So I'll have a triangle right here, I'll have a triangle right here, and then I'll have a square there, and I'll have a rectangle here. So this rectangle has area 6, this square has area 4, this triangle has area 2, 1/2 times 2 times 2. This triangle has area 1, 1/2 times 1 times 1. Now, so if I add all this up, I'll have 4 plus 6 plus 2 plus 1, that's 13. So my final answer would be 1 over 4 times the integral from 2 to 6 of f of x. This integral is equal to 13. And so my final answer would be 13 over 4. Okay, that is the average value of f of x from 2 to 6. Now let's just take a look at a couple word problems before we end this section. So here we have a function. It says the number of people in a room is given by this formula. So this will give rise to some weird half people type things, but we don't need to worry about that for now. The question asks how many people are in the room to start off with. Now, this isn't asking us for any sort of average value or anything. It's just asking us to plug a number into the function, right? So how many people are in the room to start? Well, that's what my function tells me. It's just f of 0 is equal to 190 e to the negative 0.6 times 0. This whole thing, is e to the 0 is 1. So my answer is, oh, there's 190 people to start off with. Now, how many people are in the room after 6 hours? Again, this is just asking me to plug something into my function. There's no averages to be done here. F of 6 is going to be 190 e to the negative 0.6 times 6. Here I'm going to get one of my weird half people things. I'll plug that into my calculator and get 5.1915 people. Now here's where the average comes in. So on average, how many people are in the room during the first 6 hours? So what we can kind of see is we have a function that looks something like this. You know, we start up at 190 and it decreases pretty quickly over 6 hours. I'm just saying on average how many people were there. If you just kind of came at a random time, you know, what might you expect? How many people might you expect to be in the room? And so we just want to use our formula here. During the first 6 hours, that's going to be, our b will be 6 and our a will be 0. And so we're going to do the same thing with the integral, 0 to 6 of 190 e to the negative 0.6 t dt. Now this might look a little bit bad, but you can actually do it without too much effort. You can pull out the 190, so you have 190 over 6, and then the integral of e to the negative 0.6 t is just going to be 1 divided by negative 0.6 e to the negative 0.6 t, and that's going to be from t equals 6 to t equals 0. So if you plug that into your we don't plug it into your calculator yet. We have to write down what this actually is. So we'll have 190 divided by 6 times negative 0.6 is negative 3.6. And then we'll have e to the negative 0.6 times 6. And then this is going to be minus 190 divided by negative 3.6 e to the negative 0.6 times 0. Now, if you plug that into your calculator, you're going to get 51.34 people. All right, that's the average number of people in the room over the first 6 hours. Now, before we just call it a day, this is actually all you really need to know for the homework for this section. But I just want to kind of incorporate this into the larger picture of things a little bit. So let's think about where we've seen average before. So these are two problems that you could very well get on the exam. All right, so in one problem, they give you the my position function. So like at x equals 1 here, I would be at position 2 meters. At x equals 2, I would be at position 4 meters. And we want to find my average velocity between t equals 0 and t equals 5. Here's another problem where they give you my velocity. So at x equals 1 here, I'm not at 2 meters, but I'm moving 2 meters per second, right? And at x equals 2, I'd be moving 4 meters per second. So this isn't like my position function at all, really. It's actually a lot different. And we want to find my average velocity, the same thing, between t equals 0 and t equals 5. So you really need to pay attention, and this is going to be a lot of what the review focuses on, this type of thing. But you need to pay attention to what you have in each case and what you want. And so here, we don't have a derivative. We don't have a rate of any sort, but they're asking us to find a rate, right? So we start out with a function, and they're asking us, we start with function, and they want to find the average rate of that function, all right? And so this is really asking about, this is the slope, right? That's this is from 2.2 or something like that, right? And so for this one, all we would want to do is we'd want to do s of 5 minus s of 0 divided by 5 minus 0. That would be my answer. All right, so this is the average velocity. Now in this one, we don't start with the distance function. We start with a rate, and we want the average of that rate. All right, so there's no reason that this would be a slope. This is just the same formula that we've been using in this section. So we'd want 1 over 5 minus 0 times the integral from 0 to 5 of v of x dx. Now, if you're a little bit confused by what I just said, I encourage you to talk to me. It's going to be a lot easier if we interact on this. But also, this is really